Hello everyone. For today's course, we're going to learn how to build the facade of the National Library of Kazakhstan. So, the basic shape of this library is kind of like a Mobius circle, but the facade is very interesting. Based on the different lighting data, like this side, the light is very strong, so the window will be relatively smaller than the other side. When the lighting data is very weak, so the light is not very strong, the window size will be bigger. So how to achieve that? That's what we should learn for today's course. Now let's get started. Now let's jump to the Rhino. I have built the formula. Because I don't have the lighting data, so I just teach you the method how to use some way to influence the size of each windows. So basically, it's the same as the previous course I told you. We can use the picture, where the color data is darker and where's the lighter, so that influence the size of the windows, or we can use the formula. Insert the graphic, sines, cosine, etc. So how to understand the size of this window? So we need to first, we can draw a rectangle, and then we need to pick all the points around the rectangle first. And then we select, now we use select point. Okay, we select point again. Now, once we select those points, we need to scale this point toward the central area. So we open the central and select scale. Select object to scale, and central point. Move around here, and then we need to link those points together. Now, 1, 2, 3, 4 sides, and then since all the windows here just relate to this point, so we move this point to here, and then relink to form the shape. So I break this thing. Now we need to form a surface around this area. Right? So we need to form surface, right? So once the position of this point is different, the size of the window is different. That's actually this formula mean. So based on this logic, the maximum length of this point can move should be smaller than the length of this line, right? So you can set up the maximum number this point can move from here to there. And then once we build this facade, but this facade just on the plane, is not three-dimensional shape. So later, in later course, I will tell you how to wrap this facade on the Mobius circle in the 3D dimensional way. Now, first thing first, let's check how to build this facade on the plane. I delete those things first and click here and move to the right angle. Okay. So first you need to build a plane. And I assumed the X size and the y size should be this number. You can set up larger or smaller, as you wish. Now, and then we need to use the math tip to divide this plane. That's equal, like we first build a shape, and then we form a surface, and then we need to rebuild the surface in this sector. See, rebuild surface, and then you set up 35 and then 70. Like that, we divide the surface. And then we need to, like that, yeah, divide the surface to a unit cube. Right? Otherwise link all together, it can't be operated. And then we duplicate the edge of each cube. And then we joint all the lines together. And now the step, we scale this cube into some scale. And then we distract all the points around this cube. Okay, now this step is very important. We need to seed each number of the points we just distract out. Now we can list the items and operate each point one by one. We can't operate all the points together. And now this step, you see, there's the number 3 point. You see here, there's the number 3. Now there's the number 3 I list out. There's the number 1, number 2, and number 0. See, that's very important, this step, otherwise all the things can't be operated. And once we list out the points, so we need to set up a vector where this point. So basically this kind of shape all related to the number 3 points, right? So we need to set out a vector where this point should move. So based on the logic I just explained at the beginning of the course, this number should move in this way, right? So we need to set up a vector between the number 1 point and the number 3 point. See, number 1, number 3. Now, does it move? And this vector is how much this point can move. So, see here. This thing linked to the number 3 points and the number 1 point and linked together. And give it to this vector. And use this vector to influence how much the number 3 point will move. I will explain, I will build this formula one by one in next course. Now we just explained this previously. Now, so all the size is not equal because in reality, based on the sunlight data, but in our formula, I use the picture, just like the previous course. So where's the color is darker, the size will be, let me check. Yep. Whereas the color is darker, the size will be bigger. Whereas lighter, the size will be smaller. You see, that's the rhino shape here. Okay. And then I will tell you how to process the data structure. And let's build our formula. Smooth and no error report. Okay, once we done all this operation, we need to merge all the things together. And then we need to use those lines and the new line to form the surface. Okay, I explained this formula briefly. So next course, I will tell you how to build this formula specifically, step by step. Okay, thanks for watching.